Hi everybody, this is Joe with FoozleCC, and today I'm going to teach you how to make a fairly iconic video game inside of Construct 3, and that is Snake. So with that said, let's go ahead and jump in and see what we're going to be making today. Okay, here's my finished layout of my game, so let's give it a play. Alright, go ahead and hit play here, and boom, we've got a pretty fun version of Snake here. So whenever you eat something in Snake, your tail gets longer, right? And that makes it harder and harder and harder because you can't run into yourself, and if you run into this border, you also lose. And the objective is grow as long as you can, and that's what that score represents, is my overall length of my snake. And one of the things I've done that's a little bit, oh my gosh, I can't believe I just missed that, that's a little bit unique to my version of Snake, is I've added the physics behavior to my body, and I'm actually using mesh deformation, which I've been having way too much fun with, as you can tell from my last two videos have both been on the topic, to actually show the shape of the snake using that, and the physics still work, so that's pretty cool. Alright, let's go ahead and see how this was made. Okay, so how are we set up here? I've got a handful of layers here just to keep myself organized. But the real trick of the game mechanic I'm going to zoom in on right away. On the snake head that I've called here, that is where I'm keeping the main elements for how this is all going to work. The instance variables, granularity, total distance, and granularity distance check, is I believe what I've called it. Are really some key variables I'm going to use around growing the length of my snake, as well as how smooth I want that to look for mesh deformation. It's going to trigger how many mesh points I'm going to have. And then I'm also using the car behavior on the head, because that's what's going to be controlling the movement from the player. I've disabled a couple things so that I only allow steer left and steer right. I'm using A and D to steer left and right in my version. And then I also got a timer on it because there's a couple other things I'm going to use a timer for. The other thing that's kind of a key thing, and I'm going to go ahead and give it another play with the visibility of these two helper sprites turned on, is mesh point left and mesh point right. And really this is just, think of this on one side of each side of the head as I move around. Every so many pixels that I've traveled, I want to spawn another one of these mesh points. And I'm going to use these to control the granularity of my mesh deformation and to shape my mesh deformation to make it look like the snake, aka where I've traveled. And I'm also going to be destroying these as I move forward, the older ones, so that I maintain the correct length of my snake based off how many things I've eaten. So that's kind of the trick, but let's go ahead and hit play where you can now see. Alright, so you can tell right away, I think I have it set to like every 10 pixels I travel, I spawn one of these. And I'm also keeping track of my total, my overall snake length in terms of how many segments I should really have based off what I've eaten. And what I can do then is use some math to check, well, how far ago, based off my granularity, should I be keeping my mesh points? And if it's past that, I just go ahead and I destroy that mesh point. And then I also use these two sets of objects to control the mesh deformation of a tiled sprite object, which is this green checkered piece. So let's go ahead and see how that works. Okay, so this sprite here is actually a tiled background. So I've loaded this in, and first and foremost, or going back a step, I am using assets from amazing asset provider, which is kenny.nl. If you come in here, there are a few packs that I'm using. One is the rolling ball asset pack, 2 is the fish pack here, and 3 is the pirate pack. I've just grabbed a few elements from each to make this game. This is an awesome collection of art if you aren't aware of it. I'm sure you probably are at this point, but if not, definitely go here. Everything's licensed CC0, so thank you, Kenny. I also have some music that I'm using from Itch that I downloaded, both from Micah's and DOS88 for free. Give them a follow. I'll put links down to all the assets I've used down below, as well as on my Itch page where I post this project. All right, back to the game. So now that we know where the art came from, this is, you know, the tiled background, which will actually become the snake body, so that as I grow the size of it, it still maintains, you know, aka look, I'm not stretching it, right? It's a tiled background. So it continues to look like a nice continuous snake with the checkered look and feel. And then these little jaws aren't really needed. I just thought they were a nice visual. I used the ramp from the ball game, and one of the things I did in here is I set the origin point to the pin so that I could then use a quick tween to tween the angle up and down for each one. And that's really how that's working, to make that open close effect. And then I'm using this helper sprite for collision. You'll see that during runtime, if I make this visible, I am constraining it, or I'm pinning it, actually not pinning, I'm adding it as a child to the snake head, so that it's always in the front here. And this is what's actually checking to see if I run into myself, or if I eat the fish, or if I run into the border, and boom, game over. I've got a nice fish asset here. I've got a few images that were all part of the art pack, all inside of the same sprite. I choose it randomly when I spawn it, based off which frame I'm gonna show. I have a bubble effect. I have this sand piece. I'm using the tricks I've used in some of my other videos, where on this layer of sand, I'm using an alpha clamp, so that when these get kind of close together, they have that nice effect where they join. And on here, in order for this to work, you do have to remember on this layer, when you apply this, you have to make sure it's force own texture, otherwise that won't work. And then lastly, the only effect is this explode effect. So those are my sprites. The rest are this border piece and some of these holes, just to give it a nice visual of like the sand coming in, or whatever you want to think it is. Don't know why the snake is eating the sand, but I decided that it made sense. And I really just wanted to showcase that the physics worked as I deformed the mesh. For the background, I do have a little water background effect on it, and I also have a little bit of a water effect on these border pieces, just to give it a little bit of movement. And with that said, let's go into the event sheet now. So right away, on the start of the layout, I destroy those helper sprites so I don't leave them in my layout during runtime, and then I can create them as needed, but they're already loaded. So I also set the visibility of what needs to be shown. In the beginning, I really just want the play button to be shown and everything else to be invisible. I also start my background music, Race to Mars, and then I wait for the person to hit the play button. And when I do this inside this group that I've called a knit, I do a few things. First and foremost, I set the snakehead car speed to self that speed. You don't really need to have a parameter for that. You can just keep it in the speed itself, but that's what I decided to do. If you look here, I have a speed of 500. I also go ahead and I set the position of the jaws on that snakehead where I want it, and I add it as a child so that it will move with it, and I just have it as the X and Y and the angle. So as I move my snakehead all around, these are moving with it. And then I have this tween property I mentioned, so that I can go from the current angle, which I think was at like 135, to 100, and I can ping pong and loop back and forth. And I do that with both those jaws with the right angles set up so that it just looks like it's opening and closing. And I do that every 0.25 seconds. I also set the position of my collision helper sprite, add that as a child so it also moves with it. And I create my first fish that I'm going to go and eat. And then for spawning, I'm using just some simple random placement so that it falls somewhere within the grid. I'm not doing any checks to make sure it's like not on the snake or anything. It's just totally random. It goes in one of those spots. This is where I randomly select which frame it's going to be. So I do int floor random 5 because I have 5 sprites, so that'll be anywhere from 0 to 4, which is what the frame numbering is, 0, 1, 2, 3, 4. So that's a quick trick to use to set up, hey, I want to choose one of these frames for which fish I want to see. And then I'm using a simple move to scheme on the fish so that it's moving. I thought about just leaving it static, but that was kind of boring. So what I do is I go ahead and I establish on an instance variable of the fish, move to X and move to Y. I store that so that I can do a couple of checks on that later. And then I go ahead and I initiate the move to. And I also start a timer on that fish. And that's because I want to have it every so many seconds, have some bubbles go up in the air. And on my effect of bubbles, a couple tricks here. I'm just using a bullet behavior, so it will go straight up at a certain speed. but I also have this horizontal sign on it so that it has that little, you know, bubble effect of it kind of going back and forth just a little bit. And then I have my invisibility, you know, all set. I make the play button invisible, the play button invisible, and everything else visible that needs to. This is somewhat of an important thing. So in the very beginning, I have this variable called start segment length, and I currently have it set to 2. And I have the segment length of 25. And the reason I set it at 2 initially is there's some weird mesh checks where you want to have at least, I think, 2 mesh points in terms of how many columns when you create your mesh deformation or your mesh on your sprite. So I wanted to have it at least have a starting size of something greater than just 0. So I set it to 2. And I also have my segment length that my my snake is going to be running around at before I start eating, starting at 25. And what this means is that my overall length of my snake is going to be equal to 25 times, if you come back here now to the snake head, my granularity of 10, which means I'm going to be starting at 250. And if you see here in the score, it should go right to 250 because that's just simply reporting how long my current snake is. So going back to the event sheet, what I'm doing though in the beginning is I'm going from 0 to that start segment length, and I'm going ahead and creating the mesh points that I need. And I'm positioning them in such a way that I'm starting at the snake head image point 1 for left and image point 2 for right. And if we look at that real quick, on our image points, I have image point 1 and image point 2. Image point 3 and image point 4 are used to help constrain those jaws and also the collision box. I think 3 is the jaw pivot point, and 4 is where I constrain that collision box, and that's what those are being used for. But 1 and 2 are being used for where to spawn the mesh points. And since I'm initializing this and I want it to go ahead and be a certain length, I multiply it by well, I wanted to go from left to right because of how I'm going to be numbering this. So I actually go all the way to what my start segment length is, and then which is 2. And then I multiply that by my granularity, which is 10, so that's 20. And then I go ahead and as I loop through, I add on an additional granularity. And hopefully that makes sense, but really all that means is that if I'm starting here, I fill it in like this, boom, 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 however many starting segments you assign. And now I've got at least a body to start from and to work with. I also, as I go, I'm keeping track of my segment, and segment count, I just keep incrementing by 1, and I use that in ordering my mesh points. So I know what order they're in, and then also I can do some checks on them to destroy the lower count segments. If once my snake is continuing to grow, I don't just grow indefinitely as I move, I'm also destroying my earlier mesh points. You'll see that in the later code. I also assign my mesh row to 0 and 1 for mesh point R. And that's just really, all my math is mostly just going to be on how many columns I have. There's only 2 rows for my snake always, just the top part of the sprite and the bottom part of the sprite, or the left and right, however you want to think about it. I also initiate my holes so that on a certain timer, they're spitting out that sand, which has that interesting effect. And then I go ahead and I hit play press to true. So now all this other stuff sits inside of this check of is play pressed. Inside of this play press, once I've hit play and everything's kind of, you know, invisibility and visibility has all been set correctly, there's a few things I have set up. First and foremost, under the snake head, I do an update to this total dist as well as the granularity dist check. And what this is doing is basically it's saying, look, every tick I want to update the total dist value to itself plus self.car.speed times dt. And that gives you a distance value independent of frame rate. So that's kind of an important thing to know. And now I'm able to, I have a nice variable that says, well, how much distance have I traveled overall? And I'm also doing this to this granularity disk check. And this granularity disk check, I actually reset to 0 each time I get to whatever my granularity threshold is, and which in this case is 10. You'll see that in some code here in a second. And I also just keep making sure that I'm setting my car speed to whatever my self-det speed is. One of the things that you might have noticed is I did disable, where is that? Somewhere in here, I disabled the ability for the user to control the car. And I'm just using A and D to simulate steer left and steer right. So no matter what, you're always going at whatever speed you program it in, and you can really only say, well, I can steer left or I can steer right, and that's the only control. All right, this next section is all around making the snake body now fit to the mesh points that you've created out behind you. So each time you do this, this is kind of important. Every tick, you need to go ahead and set your mesh to 0 and 2. It doesn't really matter. But when you set it to 0, what that does is it removes the mesh. And that lets you then recreate the mesh because the size of your sprite keeps changing. So you want to make sure that you're removing the mesh and adding the mesh each time based off of whatever the size might be. And once you do that, you can then set the size to what you really want it to be, which is a factor of how many mesh points you have. So in this case, I do mesh point L.count -1 times the snakehead.granularity. And I make the height 64 because that's how tall I've made my sprite and what my tiled background is always set to. Once I do that, and you'll know this from some of my other tutorials, this is kind of an important step. You do need to store inside of your snake body the original bounding box left, right, top, and bottom so that it knows what its initial reference point is that it can then stretch. So make sure that you do this before you do these next steps of set mesh point. You have to set the bounding box to a static variable to use in your math. Once you've done that, you can set size. Oh, sorry. This was me getting confused with this first one. This makes sense. Yeah, this is setting my size, the width of my snake. Well, how long is my snake now, right? It's really just a factor of my mesh point count times my granularity. This next one is where you actually set the mesh size itself. And this is using the snake body.width divided by the granularity, which is 10. And then I'm also adding 1 because you always need one more mesh point to be the full width. And then you make the number of rows is 2. And then what you can do is you can come in here and you can do a for each loop on each the mesh point L and mesh point right. And it's ordered by the mesh point L.segment ascending. And that's kind of important. So that means from basically the tail to the head, because each time I'm adding a mesh point, I'm putting on as an instance variable the segment value that I've always incremented by 1 each time. So this lets me use this for a for each ordered operation. I can go ahead and set my mesh column, which we still had to do. We already knew our row, but now we can set our column, and it's just equal to the loop index value. And then I can do the magic of the set mesh point, where I set my column to mesh point L.meshCall. I could set this to mesh row, but we know it's 0. The mode is absolute, and we use this unlerp function, and we use the bounding box left and the bounding box right, and then the .x value, and then the top and bottom and the .y value with an unlerp. And what that does is it forces the mesh point to that sprite position. And then what's really cool about that is if I have a grid of all these points, I can loop through my mesh that I've set up to be the same size of however many points I have, and I force the shape into that grid. And that's kind of the magic of how that snake is moving all around, despite, you know, whatever control you put on it. I used car, you could do something else. I just thought the car made nice smooth curves. Going to these next points, mesh point control. This is where I am creating and deleting the mesh points. So I've talked about this already, but this is where it actually occurs in the event sheet. I check, all right, that granularity disk check, is it greater than my granularity? So if it's greater than 10, what I want to do is I'm going to, add to my segment count. I'm going to create my mesh point. That similar to how I did on startup for initialization, and set my segment count and my mesh row. And then I'm also going to reset my granularity disk check back to 0 so that it keeps going through this. And every time I hit that granularity threshold, I create a new mesh point left and mesh point right. All right. Then what I can do is do another check to do some cleanup. This is important. What I do is I say, okay, my mesh point dot segments, so that's that variable that we keep sorting by. If it's less than my segment count minus my segment length, which in the beginning of the game is 25, then I want to destroy that mesh point. And that's how I make sure I always have the right number of mesh points to align to my mesh. Okay, and then this is just some of the other miscellaneous elements of the game. I don't want to spend a ton of time on this, but for fish, I am doing a few things. If my X position is greater than my my move to position, then that means I'm to the right of it, and I want to mirror my fish because that's how the sprite is set up. Otherwise, I don't want it mirrored, so it's always looking in the direction it's moving. On arrived, I want to find a new move to position randomly, and then move to it, and make sure I set my variables so I can continue to do mirror checking. And then I have an on collision with fish. This is when my snake has successfully eaten the fish. I want to go ahead and grow my segment length, and I'm using a value of 10. So if I eat a fish, I want it to grow by 25 to 35, which means if it's a granularity of 10, that means I grew by 100 pixels. And then I want to destroy the fish, and then I want to create a new one, spawned somewhere randomly. Go ahead and stop the animation, set the frame to a random fish, so it's different colored fish each time, possibly. And then also initiate the move to again, and start a timer of bubbles. And that's what you'll see down below under a different section, or right here. On timer bubbles, I want to create bubbles. And I also have a quick sound effect up above. So on timer bubbles, I create bubbles, and I'm setting it at this image point, which I've just selected on the mouth of each fish, image point 1. Right here, you can see it for each fish, right? And then I do the same thing. Inside those bubbles, I actually have 3 different types of bubbles that Kenny provided. So I randomly just select one of those, and I set my bullet angle. I also set my speed to be a little bit random, just to give it a little bit of interest. And I start my timer again so that it's always a little bit random how frequent you see a bubble. Sometimes it's in bursts, sometimes there's a little bit of a pause. Okay, and then for sand, this is that sand falling out of the top. So remember on timer sand, on the holes object that we have, we create the object, and we're doing a similar trick with the timer where there's a little bit of randomness to how often it spawns. And then I also reward you for eating the sand as the snake. So if the snake eats the sand, you grow by 1 instead of 10. So 10 pixels for each grain of sand that you manage to eat. And I also do a little bit of, I was thinking in my mind that you might have sometimes a big cluster of sand that you end up eating like all at once. And I thought it'd be kind of cool to have a few different sound effects. So I do a quick random variable, and if it's 0, do this one, this one, this one, this one, this one. And they all kind of sound the same, but they're slightly different noises. So it gives it a little bit of variety in like the, haha, I just ate a whole bunch of sand. Score is really simple. Every tick, I am just setting my value to the snake body.width. And then for effects, I'm just doing a quick check here so that on the animation finish for explode at the end of the game, it destroys that sprite, doesn't just hang out there. And this is how I handle my game over. So if I run into the border or if I run into myself, classic rules of Snake, I stop my movement so I can't move it anymore. I change the visibility to a play again button. I stop playing my music, and I also play a lose sound. I destroy a few things, and then I initiate this timer on the snake head because that doesn't get destroyed. It's just invisible sitting in the background. And we'll jump down to that real quick. And what I do there is I actually loop through all of those mesh points from the head to the tail. So I'm descending this time. And on each tick, I basically come in and I do this little thing because I have so many mesh points. I didn't want to do it on every single one. I wanted to do it every 5th one. So this is a little bit of a trick. I do .segment %5, and that's calculating the remainder of something divided by 5. So if the remainder is 0, aka every 5th, then come in here and do this. Otherwise, do this. And so what I'm doing is every 5th segment, I'm creating an explosion effect. And I'm also using this timer destroy of 0.05. So there's a little bit of a delay. And I only actually do one explode effect inside the for loop each time. I'm just using this to order it really quickly. So then I destroy the mesh point and then I stop the loop. So then the next time it comes by on the tick of destroy and I sort by descend, I get the next highest one up. So with that being said, let's go ahead and give this a play one more time now that you see how this was made, and maybe you guys will appreciate some of the little tricks that we did here. All right, so I left the visibility of these guys on, but that's okay. Let's see how we do here. All right, so eating the fish. That was a good cluster of sand. There's probably some cool game tricks that you could do in this type of game, like later on once you get a whole bunch of fish eaten, where you like this. How'd I miss that? Where you try to capture the sand inside of your body and then come back around. Oh my gosh. And eat all the sand. Anyways, I didn't score very high. Maybe you guys can do a lot better than me. I'm going to host this up on my itch page. Go ahead and download the project file, play through it at your own pace, and work through it at your own pace. Give it a play and a comment. Let me know what your high score is. And with that, everybody, thank you so much for watching. If you enjoyed, please consider subscribing, and I'll talk to you all very soon.